Today we're going to take a look at 3 new sorts. Once again, a quick reminder, a quick refresher. We have generic categories. The first one was the selection sort. What was the next one we talked about?
Linear sort?
No, we had 3 generic names.
Name sort.
Nope, still not. We had selection, we had exchange. That was the sorts where we exchange numbers. First one was one where we selected a number and moved it to a certain spot. And then the final one was called the insertion sort. We haven't done much with insertion yet, but we will today. Okay, so the next sort we're going to look at is a quick sort. And when we're done, you're going to tell me which of these 3 categories it falls into. And we could even try to figure out what the big O notation is, but it's not so easy to figure out. So the quick sort is going to do this. It's going to start with the first number, 75. And it's going to make 75 a pivot. Okay, 75 is a pivot. Now, what we're going to do is take a look at the rest of the list, and we're going to strategically move all the numbers less than 75 into a list that starts here on the left, all the numbers greater than 75 on a list here to the right. We're going to put 75 in the middle, and then we're going to let recursion take over after that. So here's how I'm going to go about getting this, this list created. So I'm going to start at 70, and I'm going to look at 68. Is 70 less than 75?
Yes.
Yes. So I'm going to move out to this one, 65. Is 65 less than 75?
Yes.
Yes. So now I'm going to move over to here. Is 84 less than 75?
No.
No. So I'm going to come out here. Is 68 less than 75?
Yes.
Yes. So I'm going to switch these two. This is now going to be 68. This guy is going to be 84. I'm going to move to the next one. I'm going to move to the next one. Is 98 greater than 75?
Yes.
Yes. So I'm going to jump out here. Is 81 less than? Because I want to put the smaller ones over.
No.
No. Is 61 less than?
Yes.
Yes. So now all of a sudden I'm going to swap. I'm going to make this 98. I'm going to make this guy 61. I go to 78. Can it be swapped? It's bigger than 75, right?
Yeah.
Yes. So now I'm going to go to the end. Is this smaller than 75?
Yes.
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 So now I can swap them. 55 and 78. I move to the next one. Is it greater than 75? Yes, it can be swapped. I come to this next one. Is it greater than 75?
Yes.
Yes. So now I come to the next one. Uh-oh, these two match. So now I found a place to stop because I matched. So now what I'm going to do is take my pivot and make it my middle position. And in doing so, I'm going to switch 75 and 1 less than the match. So this is 55. This is where that was. And now I have a first number in the right position. To the left, I have 55, 70, 65, 68, and 61. I'm going to repeat the process on this sublist, which means I'm going to make 55 my pivot. I'm going to come over here. I have 100, I have 93, 78, 98, 81, and 84. And I'm going to use 100 as a pivot and repeat the process. Okay, let's take a look at the 55. I'm going to go with the 70. Is it greater than 55?
Yes.
Yes, stop. I'm going to come over here to 61. Is it less than 55?
No.
68, is it less than 55?
No.
65, is it less than 55?
No.
I come here, uh-oh, I hit 70, which means my pivot is now going to be one less than that, and I'm going to pass this list in recursively. So the 51 is in its spot. Meantime, while this guy was working, this guy was over here working. And where does the 100 end up going? Well, let's see. Is this greater than? Nope. Is this greater than? Nope. 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 All of a sudden, I reached my end, and I'm going to swap it. So now this guy becomes 84. This guy becomes 100. My new sub list is 84, 93, 78, 98, and 81. Now, these two happen to magically work. Remember up here when I did the 75, I did a recursive call and sent this guy off to work and this guy off to work. Here, I only have a right list. Here, I only had a left list. Okay, let's take a look at this one. This is a pivot. Okay, this is greater than, so I stop. This is less than, so I swap them. This becomes 81. This becomes 93. I move over. Is it greater than? No. Is it greater than? Yes. I move back. Oh, so where's the 84 go? Well, this guy and this guy are going to switch. So there's 78. Here's 84. Here's 98. 84 is now in its right spot. What happens next? This group gets sent in with these indexes from the array. This group gets sent in. So you see how this is now going to work. This will be working. I'll be working over here. So recursion is happening almost like a binary tree in all these different areas. And slowly everything is going to be sorted into the right positions. All righty. So what I saw here early on was my pivot ended up in the middle, and I had a left list and a right list to work with. Just so happened in my left list, one of my unique cases occurred where my pivot was the smallest number. So when I got ready to do a recursive call, I didn't have to send anything from the left, but I did have to send something from the right. Over here, I had my other obscure case where it moved to the end, and my recursive call, I had one for the left list, but not for the right list. Finally, I came in here, and my pivot ended up in the middle. So now I have a recursive call here going on, a recursive call here going on. This guy was working at the same time, and on and on. What do you think?
That's complicated.
You got it or not?
Not yet.
Not yet.
Yeah.
I have a second list of numbers here. 45, 20, 50, 30, 80, 10, 60, 70, 40, 90. Go ahead and write those down. I really do wish my camera was a little clearer. $45 is going to be my first pivot. So after one pass through with this list, what would you have?
On the right side, we're comparing to see if the right side number is bigger than 45 or less than 45.
We're gonna start on the left until I find a number bigger. Then I'm gonna start on the right and move left until I find a number smaller.
Smaller than 45.
Yes, and when I do, that's when I swap them.
Okay, swap 50 and 40 essentially.
Okay, so I'm going to say no, yes. So that's bigger. I'm going to stop there. Now I come to the right. No, yes. So this is my first swap, 40 and 50.
Okay,
Now I go back to the left. I'm looking for something bigger. Then from the right, I'm looking for something smaller. So from the left, I'm looking for something bigger and I stop. From the right, I'm looking for something smaller than 45, smaller than the pivot, and I stop. I swap these guys. Why am I writing that above all of a sudden? 80. Now, all of a sudden I go, uh-oh, this guy, as I moved from the left, I matched up with what was on the right. So I'm going to swap now the 45 and the 10. So this now becomes 10. This becomes 45. And I got my first item in its exact location. So the first time I had subscript 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I sent in the subscripts 0 to 9. Here, I now have 10, 20, 40, and 30. What subscripts will I send in this time to my recursive call? 0, 1, 2, and 3. Here I have 80, 60, 70, 50, and 90. What subscripts would I send in? My beginning is here, my end is here. My beginning is here, my end is here. Do the right side. What would the right side, those 5 numbers on the right side, what would they look like after we take the pivot and get it in its right spot?
Mm-hmm. 60, 70, smaller than 80.
So this is my pivot.
The pivot, yeah.
Less than, less than, less than, uh-oh, not. Then I start from the right and I go, uh-oh, they match. So I'm going to switch with one less. So I'm going to switch with one left. This is 50. This is 80. That guy is now in its right spot. What would I have? Over here on the left, I have 50, 60, and 70 being sent in. Over here on the right, I have 90 being sent in. Over here, recursively, 10, I'm at great, oh boy, greater, 10's in the right spot. What would I send in? 20, 40, and 30. So while this is going on and this is going on, this is going on, and it just is going to keep breaking down and quickly get to a spot where everything is in its sorted position. So we have lots of recursions going on at one time. What do you think? Quick sort.
Quick way to get 2 items.
Do you have it? Now, in our 3 general categories, which one does quick sort fit into?
Exchange.
Exchange, right. Right, it's going to fit in with the exchange. Questions? Okay, I don't hear any. Moving on, our next sort, we're going to look at 2 versions of it, but the next one is actually called the merge sort. And we're going to start by taking a look at what do we mean by merging. And what you see is 2 lists of numbers, 2 arrays, okay? 2 lists of numbers, and I'm going to merge them. Now, you notice there's a lot of numbers up here. There's a lot of numbers there. We're going to be looking at different situations where there's going to be 1 number and 1 number, and we'll merge them. Or there may be 2 numbers and 2 numbers, and we'll merge them, and so on. Or it may not even match. It might be 8 numbers and 5 numbers. Okay? So let's take a look at what merging means. Merging means I start with 15 and 10. Which one is smaller?
10.
10, right? Good. So now I use the 10 and I'm going to move on. I'm now looking at 15 and 30 and I want to merge them together. Well, the next smallest is 15. So I move on. I have 20 and 30. I put the 20 and I move on. I have 25 and 30. I put the 25 and I move on. I have 30 and 35. And all of a sudden you quickly see the process of, I'm looking at two locations in an array. I'm seeing which value is larger. Whichever one is larger, I add it to my new array, and then I increment that position. I'm looking what's larger between these two subscripts, 40 and 45 values. 40 gets put in, 45. So you got the basic idea of what we mean by merging. We're going to be looking inside of an array, and we're going to say, at this location and this location, which one's smaller? And we're going to move that into our new array.
This involves being the numbers sorted into two arrays.
This involves both of these lists being sorted to start with. Okay, once they're started, then I can merge them together. So that's just a basic concept of what we mean by merging, putting two arrays together. All right, now using that concept, we're going to take a look at this guy right here, this merge sort. We're going to look at two different versions of the merge sort. The first version is called the binary merge sort. And if you went through and did a quick count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16. Why do you think this is called the binary merge sort? Well, 16 is a power of
2.
2, right. So if I have a list that is a power of 2, 4, 8, 16, 32, I can use the binary merge sort. Okay, so let's take a look at it and how this is going to work. What I'm going to do is take my list, and I'm going to start with ones. And I'm going to take this original list, and I'm going to make two lists, but I'm going to go one at a time. And you'll see what I mean by one at a time. So 75 gets moved into my first list. 55 gets moved into my second list. 15 and 20. 85, then 30, 35, then 10, 60, then 40, 50, then 25, 45 and 80. Where am I at? 70 and 65. Now you're thinking, well, you didn't do much. But remember the concept, okay? I went by ones. I took the first one and moved it in the first list, took the next one and moved it the next one, and so on. Now, what I'm going to do is take these two lists and merge them. But when I merge them, I'm going to merge in groups of 2, which is the next power of 2. So I did ones, now looking at 2s. So if I look at 75 and 55 and I merge them, I'm going to get what pair? Well, I'm going to get this pair. 55 and 75. If I take a look at the next two numbers, I get the pair 15 and 20. The next two numbers, I get the pair 30 and 85. The next two numbers, I get 10 and 35. So really, this is an order by pairs. Each pair going across is put in order. After 10 and 35, I have 40 and 60. I have 25 and 50. I have 45 and 80 and 65 and 70. Started to run out of room. So now before, when I had a list, I went by ones and created 2 new lists. Now I'm going to go by 2s and create 2 new lists. I'm going to do 55 and 75. I'm going to do 15 and 20. 30 and 85, 10 and 35, 40 and 60, 25 and 50, 45 and 80, and 65 and 70. What am I going to do? I'm now going to merge my pairs. So here I had ones. Here I had 2s. Now I'm going to merge these 4 together to get groups of 4. 15, 20, 55, 75, 10, 30, 35, 85. 25, 40, 50, and 60. And then finally 45, 65, 70, and 80. Now what am I going to do with these groups of 4? I'm going to put 4 and 4, 4 and 4, and I'm going to merge those together. So you notice I went 1s, 2s to groups of 4, which means my next group would be groups of 8, and then finally I would end up with 16 altogether. Got the idea? My next one would be to take these groups of 4, write this first group, 15, 20, 55, and 75. This group, 10, 30, 35, and 85. This group, 25, 40, 50, and 60. This group, 45, 65, 70, and 80. Now I'm going to merge these two groups together. Cha-cha-cha-cha-cha. And I'm going to create, instead of runs of 4, runs of 8. Then I would take those two and make my 2 list and do my final merge together.
How is this beneficial over any other sorting method?
Just another way of sorting. Yep. You know, that's where you start to get into this, you know, you do empirical studies with time, and you start taking gigantic lists and see which of these sorts work for what. Now, you also have to remember, we're sorting just individual items, 75, 55, 50. We could be sorting structs. You know, we could have these gigantic records that we need to sort. These could be keys that go along with it. This is, you know, so there's lots of different areas of sorting that need to be done, and why some work better than others.
Well, for the last step though, once you have roots of 8 in this case,
Yep.
wouldn't you just need to do like one long sort to get it all in order then? And then if you're going to do that though, why wouldn't you just do that at the beginning whenever you have everything all jumbled together?
Right. Something along the lines of merging is more efficient than doing 2 for loops the whole time. And again, it's
Okay.
just another way of sorting. Yep. So yeah, I can write in my groups of 8, 10, 15, 20, 30, 35, 55, 75, and 85. And I have my group of 8, 25, 40, 45, 50, 60, 65, 70, and 80. One of the things that could also happen is things could be getting in the right position quick. You know, so that the next step now would be to bring this list down underneath. You do one more through with the merging, and you would be done.
Okay.
It's called the binary merge sort. We just like looking at sorts. Questions? This one's a little easier to understand than the quick sort, I think. Yeah,
Yeah, I think so.
take that as a yeah.
What
Okay.
is the end condition for the binary merge sort?
So with the binary, we know that we're going to go through. So if I know that this is 16, I know I need to go 1s, 2s, 4s, and 8s. After the 8s, I would have a sorted list. If it was 32,
Okay.
I'd have to go to the 16s and then merge the 16s together to have a sorted list. So it's this whole idea of binary working out really nice for us. But do we always have binary? Say no.
Oh,
Nope.
No, right? Because all of a sudden I look and I have a list of 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15 items. Son of a gun. I can't use the binary merge. So what am I going to do? I'm going to switch to another merge that works as well. That could be needed. So I'm going to look at what's the natural merge sort. And what I'm going to look at is things that are already sorted. I'm going to look at little runs here. So 75, no, that's as good as it gets. 15, nope. These three are already sorted: 15, 20, and 85. 30 and 35 already sorted. 10 and 60 already sorted. 40 and 50 already sorted. 25, 45, 80 already sorted. And 70. Sorry about that. So what am I going to do? So instead of going by ones, then by twos, then by fours, this time I'm going to go by what's naturally sorted. Here's my 75. That's my first, say, cluster. Here's my 55. My next cluster was 15, 20, and 85. My next cluster is 30 and 35. My next cluster was 10 and 60. Then I had the cluster of 40 and 50. Then I have 25, 45, and 80. And finally, I have 70. So what am I going to do? I'm going to take the clusters this time. So instead of going by ones and twos, I'm going to go by clusters. Here's my first cluster. How do I know when this cluster ends? It ends when I get to a number that is smaller than it. So I know that this is a cluster. This cluster ends when I get to a number smaller than it. So I'm going to take these two clusters and make a cluster, 55 and 75. Here's my next clusters. You notice it ends when the next number is smaller. We just happen to get unusually lucky there. So let's see what we have. We have 15 in this cluster, 20, 30, 35, and 85. My next cluster, 10, 40, 50, 60. And my last cluster, 25, 45, 70, and 80. Remake two lists, 55, 75, 15, 20, 30, 35, and 85. 10, 40, 50, 60, 25, 45, 70, and 80. And I'm going to merge. 15, 20, 30, nice, 35, 55, 75, and 85. 10, 25, 40, 45, 50, 60, 70, and 80. Still with me? And finally, I would go 15, 20, 30, 35, 55, 75, and 85. Down here, I would have 10, 25, 40, 45, 50, 60, 70, and 80. And you notice every time I have different lengths, you know, they're not always ones, twos, fours, and eights. These are going to vary in length. So then finally, I would take these two lists and I would finish up summing. So here's what's going to happen in your world. A mathematician will say, hey, I got this idea. You're the programmer. Guess what I want you to do? I want you to be able to program it. Now, that doesn't mean it's going to be easy to program, but as I keep saying over and over, you need to understand the math first. Questions? Comments?
Well, since you're taking it by clusters, what if you, since it's already like the groups of sorted numbers, what if we were to just take, I mean, you know, just take the first sorted number and like take into account the, you know, the second number, which is either the smallest or the biggest of those, or no, sorry, let me rephrase that again. The first number.
Are you coming up with your own sort? Is that what you're creating?
Yes, a version of the sort actually. So instead of just combining them and then moving them at the same time, why don't we just like compare the first natural sorted, the smallest number in a cluster, and then move around with that, like a pivot or something. Not like a pivot, but and then once you have that first step done, you could just compare the last number, which is the biggest number of that
Right.
cluster, and then move along.
Yeah, I think I understand what you're saying, but in order to do that, I'm wondering if you would have to do this sort first and then modify it. Do you know what I'm saying?
Like just to get the middle numbers in.
Mm-hmm. Yep. And see, now that's where I'm at. I think I messed up here with this run. All of this run should have gone together and merged with that. And then the 10 and 60 and so on would be added at the end. Because remember I said a cluster goes until something smaller. So this should have reclustered into its own group and been merged with this group. Does that make sense, everybody?
Yeah.
Yeah. Because we'd keep going until we get to the end or find something smaller. So this, I think I taught it wrong. This cluster would match with this cluster. So it would be this, and then all of these, and then the 10 and 60, and then the 25, 45, 80 would be on the end. Yeah, so the 70 wouldn't be here. The 40 and 50 wouldn't be here. But 40, 50, and 70 would be in here. Does everybody understand where we are? Yep, I did mess up because when I said this, I'm like, wait a minute, I'm saying this wrong. And looking back. So until something smaller, that's a cluster. Until something smaller, that's a cluster. Until something smaller, that's a cluster. Until something smaller is this newly created cluster. Then this guy gets tacked to the end. This guy gets tacked to the end because I reached the end of that. So now what do I have? I have 4 groups, top, and bottom. So this would change and so on its way down. Questions on the natural merge sort? Daniel gave me a thumbs up. I like it. Everybody else can find thumbs up? I can do that. I can wait till everybody gives me a thumbs up.
Oh, there it is. I was looking for the thumbs up.
Uman found it, yeah. Okay. One more sort. I was thinking about teaching half today and then programming the other half, and then teaching Thursday and programming the other half. But I think what I'm just going to do is completely run the teaching today and then make Thursday a pair day and give you an assignment on Thursday to work on in class. All right, so I have a list of numbers: 64, 8, 216, 512, 27, 729, 199, 550, 343, 125, 93, and 666. Now in the classroom, I would have these on 3x5 cards hanging on the board, and we could move them around. But instead, it's a whole lot of extra writing for me. Now we're going to take a look at this one called the Radix Sort. And this goes back to the old days of punch cards and how each punch card had a number on it, and you could put them in a machine and the machine would actually sort them for you based on the number. And the way it worked was it would take these cards and drop them in a bin, and we're looking at 3-digit numbers. So it would go through and sort them 3 times. So we would need 3 types of sorts to go through to get everything in the right order. All right, so here's what we're going to do. We're going to start with the last digit. So if I said 729, what's its last digit?
9.
Yeah, how could you get the 9? computer-wise. If I gave you,
Modulus.
you could do modulus, right? What if it was a string? What would you use?
Char at length.
Charat, yeah. So charat, and so we have a couple of different of options. So here's what we're going to do. I want to write out how this Radix sort would work, and what we're going to do is take the list and slowly go across and dump the numbers into bins. And I'm going to start with the first number, and that is a 64. And I want to look at its rightmost digit, its ones digit, which is a 4, and I'm going to drop it in this bin, 64. Okay? I'm going to drop 8. I'm going to drop 216. I'm going to put in 512, 27, 729, 199 is going to go on top of that, 343, 125, 93, and 666.
You missed 550.
Oh, crap. That's all right. Didn't hurt us. Thank you. 550. All right, so I'm done with that list of numbers. I'm going to now use the way these are organized to create a new list of numbers and drop them in the bins. This time, instead of using the ones digits, I'm going to use the tens. Then I'm going to repeat the process with the 100s digits. So now I need to take these out of here in a certain order. Does anybody remember it that may have had it before? Going to take out the 550. Take out the 512. I'm going to take out 343, 93, 64, 125, bottoms up, 666, 27, 8, 729, and 199. This time I'm going to use the tens digits and drop them in the bins. 550 is going to go here. 512. 343, excuse me, 343 is over here. 93. 64. 125 is over here. 216 is here. 666. 27. 8. 729. And 199. I'm going to create a new list. Bottoms up. 8, 512, 125, 27, 729, 343, 64, 550, 666, 93, and 199. And now I'm going to drop in the bins one more time. This time by the ones, or the hundreds. 8, 512, 125, 27. Oh, nice. 729, 343, 64. I'm liking that bottoms up. 550, 666, 93, and 199. So now if I go one more final time, bottoms up, I have 8, 27, 64, 93, 125, 199, 340, 512, 550, 666, and 729. Ta-ta! Give me a thumbs up. Nice. Oh, I'm getting some applauses and everything. That's wonderful. All right. I'm going to give you a list of numbers and let you do the Radix sort by hand. So have paper and pencil available and see if you understand it without any help from me. A list of numbers. Let's see. 43, 111, 151, 813, 22, 811, 777, 898, 700. It's my list of numbers. Fill those bins. So after I went through and I filled my first set of bins, question comes to mind to me is, I need to start figuring out how to program this. What would I do if someone came up to me and said, write this program? Would I have two-dimensional array? Would I have, would I be wasting a lot of space with two-dimensional array?
Can that chaining thing come into play?
Could chaining come into play? You're starting to think of, from a programmer's,
What I need to find.
as a programmer, what, what am I thinking? How would I actually program this? Keep going.
Is it a array of queues?
I don't know. Could be. Is it queues or stacks? Maybe an array of stacks because I am, how am I putting this in when I get ready? I want to take out from the bottom up. Excuse me. So if I'm looking at the bottom up, I'm going 700. So this would be the first one in is the first one out.
Yeah, that's a queue.
Okay. Have my new list of numbers. I'm going to fill this time by the tens. Still good? Bottoms up, 700, 111, 811, 813, 22, 43, 151, 777, 898. $700, 111, 811, 813. I like it. 22, 43. I like it a lot, a lot. 151, 777, 898. Bottoms up. 22, 43, 111, 151, 700, 777, 811, 813, and 898. What do y'all think?
What if the numbers were only like, but for the Radix Sort only works with like different place values of numbers?
Right. We
What if
started
there's only
with the ones column, then the tens, then the hundreds. So however many columns you're dealing with would have to be how many times through you. I mean, we did 3 digits. We filled the baskets 3 times. If it was a
Yes.
5-digit number, we'd have to fill the baskets 5
5
times. But we only need 10 baskets.
Yes, but it'll still work even if we had like 10, like 1 to 99, right?
So if you had the numbers 1 to 99, you would only need to go through twice.
Points, yeah.
You'd go through the ones and then you'd go through the tens. Yeah.
Seems a lot faster, I think.
Yeah.
Seems.
So, like, wouldn't this one get worse, like the larger numbers you got, though?
Well, again, you'd have to do studies. We have 2, 4, 6, 8. We have like 9 numbers here in the range from 1 to 999. What if it was 300 numbers in the range of 1 to 999? I would think it depends on how many digits you have and how many numbers you're working with. So
Yeah.
I could see lots of variations if you looked at it that way.
Because if, like, one of your numbers was 1,000,000, this would not be very efficient.
Yeah, no, because you'd have to go through it 7 times. Or maybe it would be pretty efficient if one of your numbers was 1,000,000. But you're going through the baskets by the number of digits. So the bottom line is, we learned a couple of sortings way back in 161. We had the Dan sort, the shell sort, the bubble sort, and the selection sort. And it's like, well, that's all the sorts there could possibly be. And now all of a sudden we hit the heap sort, the merge sort, the Radix sort. We started today with the quick sort. So we have a whole bunch of different sorts going on. Okay, any questions?
Is there like a
Mm.
industry standard like best sort that they use in like all like big databases or something?
I don't know. Yeah, I don't know. Even like Java, if you have an array, you can do dot sort on the array and it'll sort it in ascending order. But what they use, I don't know. Could be one of these. It could be something that they use. But as far as big companies, I'm not familiar with it. Part of what I'm trying to get out of you folks is, wow, just because it looks like there's only a couple ways to do it, there's a lot of clever things that can be done mathematic wise to actually sort a list of numbers.